All right, so for three vectors, the operations are the same, except now you just have three variables. So if I want to find the magnitude of, let's say, A. Magnitude of A, that will just be square root of x squared plus y squared plus z squared. Pretty simple. If I wanted to find the magnitude of AB, actually, yeah, if I want to find the magnitude of AB, it would just be, what is it? X2 minus x1 squared plus y2 minus y1 squared plus z1 or z2 minus z1 squared, like that. So let's say that my vector A is -3, 5, 0, and B is 9, 6, and -4. So I have AB. I want to find the position vector of AB. So to find the position vector, what you do is it's going to be B minus A. Remember, it's terminal minus the initial. So I'm going to do 9 minus -3, and then 6 minus 5, and then -4 minus 0. And I'll have 12, 1, and -4. So this will be my position vector. So you see, it's just adding and subtracting the same thing as before when we did the 2D. If you want to write it in the equation form, 12i plus j minus 4k. So now you'll see, instead of just I and j, you'll see I, j, and k. The next part is dot product. This is the new thing. So if I have A here and B here, I'm going to do the dot product. I'm going to do this, A times B. That means dot product. This is going to remind you of what we did in matrices, kind of. What we're going to do is it's going to be the x values multiplied by each other. So we'll say dot product of A and B equals x1 times x2 plus, and then the y values, y1 times y2 plus, and then the z values, z1 times z2, z1 times z2, like that. And you're going to end up with a scalar answer. What this means is just a number, not a vector. So for example, if I have, I think I'll use from the last one. If I want to do the dot product of these two, it'll be 9 times -3 plus 6 times 5 plus -4 times 0, like that. So then I get -27 plus 30 minus 0, or plus 0. And so that'll just be -27 plus 30, 30, and that'll give me 3. That would be my dot product. And the reason why we want to do this is because this is going to help us find a special value. You might see something like this in an assignment. They'll give you two vectors, and they'll say, find this, find theta, find the angle between the two vectors. And the formula for that comes from this. The dot product equals the magnitude of A times the magnitude of B times cosine of theta. So what we just did up here, that dot product, that's the same thing as just this part here. They're both equal. And if I want to find theta here, I get theta by itself. So I have dot product of A and B over the magnitude of A times the magnitude of B equals cosine theta. Then I have to do the inverse cosine. Dot product of A and B, magnitude of A and B, and then that equals theta. So this is why we need to know the dot product, because this here is dot product. And this here is just multiplying magnitudes. So I don't believe you have to memorize this formula. I'm pretty sure that formula is on the packet. So here, this first one, find the magnitude and direction of A. This was from previous class's assignment. So find the magnitude and direction of A. So here's A, -7i plus 2j, and then I would say find the magnitude. That would be -7 squared plus 2 squared, like that. So I get 49 plus 4. That'll give me square root of 53. Well, I want -7i. That's my horizontal component. So I'm going this way, -7, 1, 2, 3, 4, 5, 6, 7, and then up to 1, 2. So then this would be my vector. And it's telling me that this magnitude here is square root of 53. All right, so what I did here is, this is my horizontal component, this is my vertical component. And so technically what you have here is your x and y. And when you're finding the magnitude, I should probably draw this first. I'll say, okay, first I'll do -7. So 1, 2, 3, 4, 5, 6, 7 here, and then up 2. So this is my vector right there, just like that. And so if you look here, I actually have a right triangle, like this. We know that's 2, and we know this is -7. And so that's what I did here. I did the Pythagorean theorem. This was the x value, this was the y value. And so when you do that, you'll find the hypotenuse, which is square root of 53. Now that we have this triangle, we got to find this angle so we can get the direction. Remember, the direction goes from this x-axis here over here. I want to know, what is this angle from here to here? And the way I do that is, if I find this angle down here, I subtract that from 180. And to find that angle, I'll do SOHCAHTOA. This is opposite, this is adjacent. So inverse tan of, I'll do opposite is 2 over -7. And if you do that, -15, which means this is going to be 15 degrees. Or actually at 15.9, 16 degrees. So what that means is, to get this whole thing, it's going to be 180 minus 16. And that's going to be my direction angle. So that would be 164 degrees. So this is my magnitude, direction angle. So that's your answer. Now for this part, this is for the new formula. We're going to do dot product over the magnitudes, and then inverse cosine of that. So to give me theta. So A is -7, 2. Put that here. 1, 2, 3, 4, 5, 6, 7, 2. That's A. B is 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So then that's the second vector. So we want to find this angle here, that theta. So the angle between A and B. So if you look here, what we need is, we need the dot product, and we need the magnitudes. So first, I usually find the dot product first. So we have -7 and 2, 7 and 8. -7 and 2, and then 7, 8. The dot products, that'll be -7 times 7 plus 2 times 8. Let's see, that's a -49 plus 16. If I add those together, so that's going to be 43 is at -33. So then that is my dot product. Dot product. Now I need the magnitudes. So luckily here, I already found A. A is square root of 53. Now we have to find B. So again, we have a right triangle here. We know that this is 7 and this is 8. We got to find not the angle, we're going to find the magnitude. So it's just going to be square root of 7 squared plus 8 squared. And if you're not seeing how I'm getting this, let me write the whole thing out. Let's say this is h. Doing h squared equals 7 squared plus 8 squared. So then you take the square root of both sides to get h. That's where I get square root of 7 squared plus 8 squared to find out how long that line is, or the vector. So that'll be 49 plus 64 and the square root. If I add those together, I should get 113. So now I have all the numbers I need. This one would be 113 square root. Now I just insert the numbers where they belong into this equation here. So the dot product was negative 33, that's on top. On the bottom, the magnitude of A was square root of 53. The magnitude of B was 1 square root of 113. And I do cosine, rewrite that, 1 square root of 113. And then cosine inverse. You just type that in the calculator. 15.2 degrees. So then this would be 115.2 degrees. And that's it.